Section 6.3. Today we're going to look at writing indirect proofs. So our objective today is I can write an indirect proof. Up until now in class, we have written what are called direct proofs. We have started with the given, then reasoned logically until we arrived at a conclusion that had to be true. Now it turns out that especially in higher level math, sometimes it's impossible to write a direct proof. But it is possible to prove something using what is called an indirect proof. Okay? And in an indirect proof, and this is the key, you start by assuming what you want to prove is false. In other words, you assume the conclusion is false. By saying that the opposite is true. Okay? So for instance, if I had this conditional statement, if length of AB equals length of BC, then triangle ABC is not scalene. Okay, so that's my statement, and remember that in this statement, this is the hypothesis, and this is the conclusion. Okay, so if I wanted to write an indirect proof, my first line of the indirect proof, and by the way, indirect proofs are usually done in paragraph form. We would start out by saying, assume temporarily that triangle ABC is a scalene. Okay, and so in other words, we start out saying the opposite of what it is that we want to prove. And then when we actually do the proof, we continue to reason logically until we get a contradiction to the given. Okay, so we reason logically until we contradict something that we know for sure is true, and the given has to be true. And so if that's true, then our original statement has to be false. Okay, so let's look at another example. If I had the conditional, if n squared is greater than 6n, then n is not equal 4. Right, so the first sentence in my indirect proof would be the opposite of what I'm trying to prove. I'm trying to prove that n is not equal to 4. So I start out by saying, assume temporarily that n equals 4. Okay, so that would be my the first line in my indirect proof. Then I would reason logically until I got something that contradicted the given. Okay? And once I get that contradiction, then I say, well, then my starting statement had to be false, and therefore the opposite is true. All right, let's do one more. If measure of angle 1 equals measure of angle 2, then segment XY is parallel to segment CD. Okay? Well, the first line in my indirect proof would be assume temporarily that segment XY is not parallel to segment CD. Okay? And so we assume the opposite of what we're trying to prove. That's the first step. Okay? And as I said, paragraph proofs are usually written in paragraph form. And so the object is here. Here's the main things. Number 1, assume temporarily the opposite of the conclusion. Number 2, reason logically until you contradict the given or hypothesis. Okay? Because the given or hypothesis is a known fact. Number 3, you state the original assumption. In other words, what you said in line 1 is false. And therefore, the opposite must be true. Okay? So indirect proof has basically those 4 main steps. Okay? So let's go through a whole proof. Okay? So given AC is equal to RT. Length of AC equals length of RT. And AB equals length of RC. Oops. Length of AB equals length of RC. And angle A is not congruent to angle R. Prove that length of BC is not equal to length of ST. Okay, and here's our picture. Okay, this is C, this is A, this is B, this is T, this is R, this is S. And we know that AC is congruent to RT. And we know that AB is congruent to RS. Okay? So we want to do an indirect proof. So we start out by saying the opposite of what we're trying to prove. So we say, assume temporarily that BC, that length of BC equals length of ST. So we're assuming that this equals this. Well, if that's true, then triangle ABC has to be congruent to triangle RST by side, side, side. And then angle A has to be congruent to angle R by corresponding parts of congruent triangles are congruent. But this contradicts one of the given statements. But this contradicts the given information that angle A is not congruent to angle R. Therefore, the temporary assumption that length of BC equals length of ST must be false. So it follows, oops, that length of BC is not equal to length of ST. Okay, and that is our proof. All right, let's try another one. Given triangle ABC, where AB is congruent to BC. Prove that measure of angle A is not equal to 90 degrees. Okay, so we start out, we want to do an indirect proof. So we start out by saying the opposite of what we want to prove. So we say, assume temporarily that measure of angle A equals 90 degrees. Well, if those two sides are equal, we know this and this have to be congruent angles by the isosceles triangle theorem. So we know then measure of angle C also equals 90 degrees. And measure of angle A plus measure of angle B plus measure of angle C is equal to 90 plus measure of angle B plus 90, which is greater than 180. But this contradicts the fact that the sum of the measures of the angles of a triangle is 180 degrees. Therefore, the temporary assumption that measure of angle A equals 90 must be false. Hence, it follows that measure of angle A is not equal to 90. All right, let's do just one more, okay? Given, let's do this one. If n squared is greater than 6n, then then n is not equal to 4. Okay? So this is our conclusion, so we assume temporarily the opposite. So assume temporarily that n equals 4. Then n squared equals 16, and 6n equals 24. But this contradicts the given that n squared is greater than 6n, since 16 is not greater than 24. Therefore, the temporary assumption that n equals 4 must be false. Hence, it follows that n is not equal to 4.